What's up, guys? It's Taylor. Welcome back to The Blueprint, a channel in which we talk about software engineering topics and, sometimes about things. Sometimes, but not today. Today, I'm going to teach you all about variables and expressions inside of Java. Let's go. If you've ever taken an algebra class, you're already very familiar with the concept of variables. If you remember things like x equals 12 or solve for x, in that case, x is the variable, and variables function very similarly in programming as they do in algebra. So, inside of Java, there are 8 main data types, and they are short, long, byte, integer, float, double, char, and boolean. Now, of those 8 variables, 6 of them actually deal with numbers and 2 deal with something else, and we'll talk about those a little bit later. So, of the 6 that deal with numbers, you might be wondering, why do you need 6 variables to just hold numbers? And that's because some of them deal with decimal types, such as 1.33, 2.22, and some deal with whole numbers such as 1, 2, 3, 4, and 5. But the real reason we have such an expansive range of variables to deal with numbers is based on their size. Now, there are some data types such as byte or short that deal with smaller numbers and have a smaller range. And then there are some data types such as integer or long that deal with larger numbers and that can hold a larger range. I'm going to go ahead and place some ranges on the screen so you guys can see, and you can see the different ranges of different data types. The range is the real reason why we have so many different data types. So let's go ahead and talk about those 2 auxiliary variables types I talked about. Let's talk about Boolean and character, better known as char. Boolean is a very weird data type. It can only hold true or false. It cannot hold any other value. So that might seem a little weird for you, but you'll realize how powerful this really is a little bit later on in this series. And our final data type is actually character, better known as char. So char is also limited like Boolean in what it can hold, but it can hold a little bit more than a Boolean. It actually can hold any Unicode value. So if you're not familiar with Unicode, I will go ahead and place some links in the description box below for you, but I'll give you a quick rundown on the concept. Essentially, any letter or symbol, such as @ or exclamation point, can be mapped to a number, such as 97, 126, etc., etc. And when the computer sees this number, such as 97, 123, 34, it will go ahead and display the correct symbol. So character is kind of unique in terms of it can only hold one value. So what I mean by that is you can't put a or a exclamation point or a however many other characters. It can literally only hold one value. That's just a really quick rundown, and that's a lot of technical jargon. Let's actually get in here and use these values. So let's go back to algebra. So you remember that whole statement, x equals 12? They kind of actually did a lot of the work for you. The only thing that's actually missing from this statement is telling our computer what type of variable is it? Is it an int? Is it a char? Is it a Boolean? Let's go ahead and look at the syntax and figure out how to actually declare a variable in Java. So let's say we want to create a variable called x, and we want it to equal 12. I'm going to go ahead and create it as an integer. You'll see that I'm actually typing the type int by the name x. The equal sign, which is declaring that x is going to equal something, and then I want it to equal 12. And so I'm writing the number 12 here. And I'm finishing it with a semicolon. In Java, when you finish a statement, you need to put a semicolon there so the computer knows that this is the end of the statement, or this is the end of whatever you're doing. So very, very simple. And that's how you declare any variable inside of Java. So let's go ahead and create a char. So we're going to create a char. That's our type. What are we going to name it? Let's just go ahead and name it symbol. And we're going to say equals. Let's go ahead and provide the @ and finish it with a semicolon. Very simple. Let's actually go ahead and print out x, and not the letter x, the actual value of x. How would you go about doing this? I will tell you the answer in a couple of seconds. Awesome. I hope that you tried to figure that out on your own. So if you watched our previous video, you might remember that you can print out things with system.out.println. Now, if you use the syntax from the previous video, you might have used quotes. You might have got something like this, just x, instead of 12. And you might be wondering, well, what happened? Using quotes with the system.out.println statement actually takes the literal value of what you're typing and displays it. So because you wrote X, it literally gave you X again. So we don't want X, we want the value of X. So if you take the quotation marks off around X and you just provide it with X, it will actually give you 12. Go ahead and do that and press play and see what happens. Awesome. So this is how to create variables. So let's actually talk about expressions. Our math class is going to come in handy for us once again because expressions work pretty much exactly the same as Java as they do in our math class. So in Java, we also have addition, subtraction, multiplication, and division. And they work the exact same way that they do in math, except for division. So in Java, when we do division, we only get the whole number. We don't get the remainder. Let me give you an example of this. If we were to take 5 and divide it by 2, it's actually 2.5. However, in Java, you're only going to get the value of 2. It destroys the remainder. It doesn't keep it. So this can be a little bit difficult sometimes when we're dealing with division. So it's very important that you choose the correct data type in order for you to preserve your remainder. We also have another operator in Java that you might not be familiar with, which is the modulus operator, better known as the percent sign. And that's here to help us gather that remainder that is lost within division. So if we were actually to take 5 divided by 2, it's actually 2.5. We would only get 2, and that 0.5 would be lost. So in order for us to access that remainder and figure out what it is, we would use the modulus operator. Now, if we actually do 5 modulus 2, we'll get 1. And you might be like, what the heck? How does this work? So let me actually show you some long division. So let's take 5, draw the little house for 2. So 2 goes into 5 2 times. And we have a 4. Now, if we subtract 5 from 4, we get 1. And that's your modulus operator. Modulus can be a very tricky operator to understand, but as we go on and use it in more examples, you'll be able to see its usability. And so now it's time for our first challenge because you learn way more by doing than just listening to me. So let's create 3 variables. I want you to create a variable called x that is an integer and set it equal to 1. I want you to create a variable called y that is also an integer and set it equal to 2. And I want you to create a final integer called total, and I don't want you to set it equal to anything. I'm going to go ahead and help you out with this one. To create a variable that does not have a value, you do the type, we're going to do integer, the name, we're going to do total, and just a semicolon. This is how you create a variable that does not have a value. And so what I want you to do with all these 3 values is I want you to add x and y and store the result in total. And then I want you to print out total on the console window. So let's complete challenge 1. Using the syntax that we learned before, let's go ahead and create the first variable called x. It is an integer, and let's set it equal to 1. Let's create our second integer, y, and set it equal to 2. And we'll create our final integer total and set it equal to nothing. Now what we're going to do is set total to be equal to x plus y. Now that we've done that, we're going to go ahead and print out total. A shortcut for IntelliJ for printing things out is SOUT, which is a shortcut for system.out.println. So for challenge 2, I'm going to take it back to your math class and I want you to solve for x. Now, of course, you can use your math skills to figure out what x is, but I don't want you to do that. I want you to use the computer. Using the skills that I've taught you so far, the addition, subtraction, multiplication, division, and modulus, as well as being able to print something out on the console, I want you to print out the value of x for me. How would you do this? Now you have a little bit more creativity in this problem, and there's actually more than one way to solve this problem. I'm super interested to see in what you come up with. So I'll come back in a couple moments and show you how I would solve this. Now let's go ahead and tackle challenge 2. Now there's more than one way to solve this challenge. If you think about it a little bit,
we really only need to print out x. We don't really need to do much else. So what we can actually do is just do 29 plus 13 and ask the system to print out the result for us. We will get 42. Another way to do this is to do the exact same thing we did before. Create an integer for 29, create an integer for 13, and create an integer to store the result. Once we do the addition, we can then print out the result of the addition, which will also be 42.
And just like that, we learned how to create variables. We learned about different variable types. We learned that our math class was actually useful. We learned about how to operate on variables, and we learned how to translate thoughts and sentences into actual code. All in one video. That was a lot. So hopefully you're beginning to see that programming really isn't that difficult, and it really just builds on things that you already know. Our next video in this series is actually going to be about strings, because they're not as simple as our floats, doubles, or booleans, but they're not as difficult as more complex things. But strings are very important in the world of programming. So hopefully I'll see you back here next week so we can learn about strings together. Hello. You're still here. Yeah, the video ended like, 20 seconds ago. Yeah. There's nothing left. But since you're here, I might as well tell you that there's other videos in my channel related to programming if you're interested in that. I got videos on how to solve, whiteboarding questions. I got videos on, how to build tic-tac-toe. I got other videos in this Java series. I got videos, for you to watch. You could always subscribe, especially if this isn't your first video. You should probably subscribe, but we don't judge over here. So do what you want, but you should probably subscribe. Just saying. But yeah, video's done. You're just here, intimidating me. Stop it. I'm gonna go back to reading now. Okay, thanks. Have a good one.